Good morning, dear students. How are you all? Hope you all are doing good. So, welcome to chemistry class today. As you already know, we have already started with our second chapter of chemistry, that is acids, bases, and salts. You've already done acids as well as bases. So, let's start with today's topic, that is salt. Today, we are not going to complete all the salts. We'll be just talking about the introduction and few properties of salts, and then we'll be talking about our first salt, that is sodium chloride. Try to understand, children, first of all, how the salt is formed or what exactly the salt is. You have done in acids and bases when we talked about neutralization reaction, which is taking place between an acid and a base. When acid reacts with base, the salt is formed along with water. Now let's talk about family of salt. Salts having common acidic or basic radicals are said to belong to the same family. For example, if we talk about sodium chloride, that is NaCl, and calcium chloride, that is CaCl2, they both belong to the same family, which is known as chloride family, because both are having chlorine in them. For example, sodium sulfate, potassium sulfate, aluminium sulfate, they all belong to sulfate family similarly. And another example you may have calcium chloride, calcium sulfate, they belong to calcium family. Zinc chloride, zinc sulfate, they belong to zinc family. So now try to understand something related to conduction of electricity. As you have already done in acid and bases, and you know now that acid and base solution can conduct electricity due to the formation of mobile ions. Similarly, when salt is also dissolved in water, it is also giving rise to ions, and these ions are responsible for the conduct of electricity, same as in the case of acids and bases. Here you can see an example. If you dissolve a pinch of salt, that is sodium chloride, in water, it gives rise to sodium ions and chloride ions, and it is also going to conduct electricity. Now, pH value of acidic, basic and neutral salts. First of all, try to understand, children, there are three kinds of salts possible: acidic salts, basic salts and neutral salts. Neutral salt, first of all, we'll be talking about. Salts which are produced because of the reaction between strong acid and strong base are neutral in nature. And you know now the pH value. The pH value of the neutral is always equal to 7. Examples for the neutral salts are sodium chloride, sodium sulfate, etc. Basic salts. Salts which are formed after the reaction between the weak acid and strong base. See, whatever is the strong, the same will be the salt. Here the strong base is there, therefore the salt formed will be basic, and its pH value is greater than 7. For example, sodium carbonate, sodium acetate, etc. Now, acidic salts. Salts which are formed after the reaction between a strong acid and a weak base. Here the acid is strong, that is why the salt formed will be acidic. And of course, the acidic salts will be having pH values less than 7. For example, ammonium sulfate, ammonium chloride, etc. Now, cause of formation of acidic, basic and neutral salt, which is very important. When equally strong acid and base react, they fully neutralize each other. Due to this neutral reaction, the salt formed will be neutral. When a strong acid reacts with a weak base, the base is unable to fully neutralize the acid. Therefore, there will be a formation of an acidic salt. And when the strong base with weak acid, of course, the formation of a strong basic salt will be there. Now, few characteristics of salts. Most of the salts are crystalline solid. Salts may be transparent or opaque. Most of the salts are soluble in water. Solution of salts conduct electricity. Just now I have told you, because of the formation of ions. The salt may be salty, sour, sweet, bitter, or any of the taste. Neutral salts are odorless, they don't have any smell. Salts can be colorless or even colored. Now, related to this property, that why few salts are colored and why few salts are colorless, we'll be talking about a very important term, that is water of crystallization. Many salts contain water molecules which are known as hydrated salts, means when water molecules are attached to them. The water molecules present in a salt is known as water of crystallization, and there is always a fixed number of water molecules which are attached to these salts. For example, if we have copper sulfate, pentahydrate, the formula always will be CuSO4 5H2O. You cannot change the water molecules, number of water molecules here. It has to be 5. Similarly, in FeSO4 7H2O, the water molecules have to be 7. Now, CuSO4 5H2O is blue colored salt, whereas FeSO4 7H2O is a green colored salt. When this CuSO4 5H2O, that is copper sulfate pentahydrate, is heated, it loses its water molecules of crystallization, and again it changes into white color. So this is anhydrous salt, and when it was having the water molecules of crystallization with it, it was a hydrated salt. Now we'll be talking about our first salt that is to be studied in class 10, that is common salt. The name common salt is, or the table salt is, a common name, and the chemical name is sodium chloride, and the chemical formula for it is NaCl. It is also known as table salt, as I have just told you, because we are using it in our food, in our kitchen, and it is formed between the reaction sodium hydroxide and hydrochloric acid. The reaction is between sodium hydroxide and hydrochloric acid. Both are strong acid and a strong base. Therefore, the salt will be neutral. pH value will be 7. There are two major methods of obtaining sodium chloride. One is from seawater and another is by rock salts. Now, common salt is also used for making other chemicals from it. For example, the very important chemical here is sodium hydroxide, that is NaOH. It is also a strong base, and it is also known as caustic soda, which is a common name for it. It is obtained by electrolytic decomposition of solution of sodium chloride, that is brine. Children, try to understand here what is brine. Brine is actually a saturated solution of sodium chloride. Saturated, you know, when no more amount of solute can be added to the aqueous solution. In the process of electrolytic decomposition of brine, it decomposes to form sodium hydroxide, that is caustic soda. In this process, chlorine is obtained at anode and hydrogen gas is obtained at cathode. This you have to remember, children. This is something very important, that which gas is liberated at anode and which is liberated at cathode. And this whole process is known as chlor-alkali process. And the reason behind is why the name is chlor-alkali process, because chlor is because of the formation of chlorine, and alkali, of course, we are producing NaOH. That is the one of the example of alkali. Now we'll be talking about these byproducts which are formed in chlor-alkali process. They'll be used for various important purposes. For example, hydrogen gas, it is majorly used as a fuel. Chlorine gas is used in the water treatment plants and in making of PVCs, CFCs, pesticides, and so on. Sodium hydroxide is used as a degreasing of metals and in the manufacturing of paper, soap, detergents, and bleaches, fibers, etc. That's all about NaCl, sodium chloride here, children. Today we are going to do this much only. And for making you understand in a better way, I am just posting a YouTube link and PDF along with this video. Kindly go through the link, and if any doubts, feel free to ask me during your Zoom class. Your doubts are always welcome. So, all the best, dear students. Do well.